Hi, and welcome to this episode of Technology Made Simple and Relevant. I'm Ken Wygand, Director of Advanced Technology Solutions at Custom Computer Specialists. Today I want to talk to you about software-defined wide area networks, or SD-WAN. Let's start off by talking about software-defined. What exactly is software-defined? It's the latest buzzword in the industry. Software-defined access, software-defined networking, software-defined WAN. Pretty much soon someone's going to come up with something like software-defined software. I don't know what that would be, but it's going to be coming. To start off, software is nothing new. Software is attached to just about every piece of hardware that we have today. So if we think of it like layers, software rides on top of hardware. The software controls and manipulates the hardware. Often, software is how you interface with the hardware. So what software defined really means is that the software is taking on a much higher sophistication than we have today. It's really a level of policy above the traditional hardware and software layers that we're familiar with. This layer rides on top of the software. The key is that it's really another level of abstraction between the layers, whereby we can interact with the hardware and the software at a policy level instead of a more granular and sometimes cumbersome level. So we define a policy, and the policy is what interacts with the software. So let's jump into what software-defined wide area networking is, and I'll give you some examples. Now that I've introduced what software-defined is, what is a wide area network? It's the means and connections through which different physical locations connect with one another. So if you have two physical buildings, they may communicate with different types of connections, right? So you might have building A, building B, and they're going to connect with different types of connections. So you might have, for example, a fiber optic connection. You might have a MPLS connection. You might have another connection, which is a cable modem, which connects through a VPN, through the internet. And these connections interconnect the buildings. Today, our users are expecting what we refer to as utility-grade networks, meaning that there's an expectation that it just always has to work. Similar to when you use a utility like plugging in your laptop into an electrical outlet or you open up a faucet, you have a reasonable expectation that that thing is going to work without exception. As such, many organizations have not just one or even two WAN connections, sometimes 3, 4, even more circuits in between buildings. Traditionally, there have been two major challenges with having multiple WAN circuits in between buildings. The first challenge is that reliable circuits are usually very expensive, okay? The second challenge is that given the way that routing works, which is at the software level that we talked about before, it's very difficult to configure and troubleshoot the efficient use of multiple circuits. Routing wants to go one path. So you have a router and it can go different ways. Routing wants to take one path, and it's easy to set a primary path and a backup path if that circuit goes down. But in that scenario, the backup circuit, which you're usually paying a lot of money for, sits dormant while the primary connection is working properly. So the best we've been able to do today is to try to load share, not load balance, but load share across two or more circuits by sending certain traffic one way and sending certain traffic another way, and having them then fail over in case either circuit goes down. But the rules are static and it doesn't adapt based on how much traffic is going on each circuit and also how each circuit is performing. So now let's introduce SD-WAN. It's that additional layer of abstraction between the policy that you want and the complex configurations to make everything work. So SD-WAN not only has full visibility to the current state of the circuits, including the load that's on the circuit, the link quality, and a lot of other parameters that are related to the circuits. But it doesn't just know up-down. It incorporates that knowledge and the ability to define your policy that you're looking for, the policy that we have, right? Has the ability of defining the policy based on the specific behavior and the specific requirements for each application you'll be using over the WAN. So let's say I have a couple different applications. So let's say I have application A, I have application B, application C, and application D, right? And these are different things that are going to be running on the circuits. Let's say application A is a critical business application. It needs a certain amount of bandwidth, and it needs let's just say it can tolerate a certain amount of delay, and it must be up and prioritized above everything else. It has to be prioritized. Then let's say I have an application that may be buffered video, right? Buffered video. Okay, this uses a lot of bandwidth, but it's not really delay sensitive because it can tolerate, it has a buffer, so it can tolerate some levels of delay and buffer things together. So I could define a policy for that. Then I might have, let's say, email, right? Okay, email is very important that it gets through, but I don't really care if it goes through in half a second or 2 seconds or 5 seconds, as long as it gets through. So I have very low bandwidth and very small delay requirements. Then I might have, let's say, internet radio, or scavenger traffic, as we call it, which I don't really want to use my expensive high-performance links to transmit non-business traffic on my network. So with SD-WAN, I simply define my application requirements, my policies, and with its intelligence of the performance of the links that I have, it will ensure, for example, in this case, maybe that application A always goes over MPLS. And if the MPLS fails, then it'll go over the fiber link, okay? Or if it's congested, it might go over a different link. If application B, for example, is buffered video, so it might always take this cable modem first, right? Application B might always take the cable modem first because this is very cheap, but it's not very reliable. So I might take the cable modem first and then use the MPLS link if the cable modem is down. Email might try to use MPLS first, but if it's congested, it'll fail over to one of the other links, but it'll fail over to all of the links because it's very important that my email gets through. Whereas now the internet radio might only ever use the cable modem. And that's it, because that's my low-cost internet, and it might only be able to use that if the internet, if the cable modem is not congested with other traffic. So it only gets what's left over, if anything. This is a very simplified overview of SD-WAN, but the takeaway here is that SD-WAN puts power in your hands that you've never had before. It allows you to take utility-grade networks to the next level and offer your users this type of behavior while lowering your costs of expensive circuits by offloading traffic to the cheaper alternatives. As always, if you have any questions at all, feel free to reach out to me. Again, my name is Ken Wygand from Custom Computer Specialists. I hope you enjoy the rest of your day, and thank you for watching.